Okay, so continuing on blood grouping, particularly blood group mismatch. So here we are going to talk about delayed transfusion reaction caused by non-ABO antigen. So previously we talked about the acute reaction because of the anti-A and anti-B antibodies. Now we are going to talk about delayed reaction due to non-ABO antigens. Particularly we are going to talk about the RH antigens. So usually this will happen due to repeated transfusion of ABO matched blood that is incompatible for other blood group antigens, particularly RH. Okay, for example, you are taking a positive blood and infusing into negative donor. So if this is happening, then the antibodies against RH antigen will be produced. So as I said before, IgG molecules will be produced, and these molecules are not maternal antibodies, so they will be produced only upon exposure. And these are single molecules, single Y-shaped molecule, not 5 molecules. So these molecules are, when they are produced, it's a slow response because it has to get exposed to the immune system and then it has to produce. So it will take around 7 days to produce these molecules. So when these molecules are produced, it's sort of like a less aggressive compared to the other ABO mismatch because that's maternal antibodies, pentavalent antibodies, here single valent antibodies. So these antibodies will also bind to the red cells, particularly to the RH protein present on the red blood cell membrane. Okay, and then when this is complex is formed, similar to what happened to the ABO mismatch, the complement mediated system will lyse everything here. Okay, particularly the phagocytes, for example, macrophage can bind to the complex and then try to lyse everything. So basically destroying the newly entered RBC cells which has positive blood group. So that's why this is delayed response, okay, mediated through RH antibodies that are produced upon exposure, and this will also lead to the lysis of red cells. Therefore, we need to make sure that this is not happening, and the lysis will cause the same symptoms similar to what happened in ABO mismatch. Okay, so how can we do the blood grouping testing? So basically the agglutination testing, that's a routine test that we do. In a glass slide, we take 4 drops of blood and then you mix with different types of antibody and use a finger, use a toothpick or any small needle, and then just to mix the blood with the antibody and watch the agglutination in front of you. For example, if a person got a group A blood, they will be carrying anti-B antibodies in their body. Okay, so when you add anti-A antibodies to this blood, it will precipitate or form agglutination visibly, but with anti-B, nothing will happen because they don't have B antigen. So in B group people, they will have B antigen. So when you add anti-A antibody, nothing will happen. But when you add anti-B antibodies, the agglutination or precipitation will happen. So you will know that person is B. But what about the group AB? So when you add anti-A and anti-B antibodies, both of them will precipitate here. So which means they are positive for A, positive for B, therefore they are AB. And then O blood group, they will not react with any of these antibodies, anti-A or anti-B, because they don't have both of these antigen. So in addition, people will also do for RH antigen, and if the agglutination is happening there, then they are positive for RH. So this is how the blood grouping test will be done in a glass slide using few drops of blood. Okay, so here, for example, anti-A and then anti-B, so anti-AB. So this type of test can be done in large scale in hospitals using multiple antibodies and samples collected from multiple patients at the same time in microtiter plates. Okay, based on the reaction, they will identify what blood group it is. So based on the pattern. So you can go through this and find out whether you can identify the blood groups of these particular people and double check with these groups. Okay, that's sort of practice for you guys. Okay, what is the transfusion compatibility in general? So we talked enough about the ABO antigens, RH antigens. So now we're going to talk about the compatibility as sort of like a quick guide to see if somebody got this blood group, what type of blood we can infuse to them. Okay, so if a recipient person is A blood group, they will have A antigen and they will have anti-B antibodies. Therefore, they are compatible for A blood group because that's what they got, plus O blood group because that doesn't have both A and B antigens. They are not compatible. Sorry, they are not compatible for B and AB blood because they have any antigen, but they have anti-B antibodies. So they cannot take B or AB because that will lead to mismatch. OK, if the recipient is B, they will have B antigen, anti-A antibodies. So therefore, they can receive their own blood, B blood group, B blood, and O blood because it doesn't have any antigens. But they cannot receive A blood group or AB blood group because that will react with this antibodies and it will get destroyed. What about A? So they will have both A antigen, B antigens, but they will not have any antibodies. Therefore, they can receive blood from anyone. A donors, B donors, AB donors, and O donors. There is no incompatibility for them. And what about O? They will not have any antigen, but they will have both anti-A and anti-B antibodies. OK, so they are compatible only with O blood group people. OK, they cannot get blood from A, B, or AB, but they can give blood to anyone. OK, but they cannot get it. So in addition, we need to check positive or negative. OK, for positive people, you can give positive. For example, if they are A positive, then you can give A positive blood or O positive blood or O negative blood. It's really important that you check that as well. OK, you only thing you can't do is for a negative person, you can't give positive blood. OK, try to remember that. For positive people, you can give negative blood. It's not a problem. OK, in generally, O blood group, specifically O negative, is the universal donor. You can just close your eyes straight away. You can infuse this blood to anyone because it hasn't got AB antigens. It hasn't got RH antigens. So they are called universal donor. So generally people will call O blood group as universal donor because you can give to most of the positive people, and the positive people are the most abundant ones, but they can't give O positive to O negative or A negative people. So try to remember that single small differentiation here. And then AB blood group, particularly AB positive, is the universal recipient. OK, AB positive is universal recipient because they can receive any type of blood, including AB negative or negative, anything. So O blood group, particularly O negative, is a universal donor. AB blood group, particularly AB positive, is the universal recipient. In practice, it's not that simple due to the presence of other antigens, particularly, for example, RH, and other matches will also be done. OK, so this is why cross matching has to be done between the donor and the recipient prior to transfusion. Since there are many blood groups, more than 20 different types of blood groups, and more than 400 variants available on red blood cells, and there are some rare blood groups as well, which we are not going to touch because this is just a basic lecture on blood grouping. So the suitability of blood transfusion should be double checked by cross matching. So what is cross matching? What are they doing here? So the blood cells from the donation are mixed with plasma of the recipient because, as we know, the plasma will contain the maternal antibodies, either anti-A or anti-B. So when you mix the red cells or blood cells isolated from the donor with the plasma of this blood, you will see whether it's precipitating or not precipitation. So if it's agglutinating here, then what is it showing? It is not matching because the antibodies are reacting to the red cells. If you transfuse this blood, then it will lead to lysis. If there is no agglutination, then it's definitely matching. You can go ahead and transfuse. OK, so when you use this plasma, it will match all sort of other antibodies present in the body as well. OK, it's not just ABO. If there are other maternal antibodies raised against red blood cells or other blood cells, we can double check everything here. That's why you need to do the donor recipient compatibility. So the agglutination is responsible or indicating the incompatible blood. OK, so other blood groups. So it's all for your information. You can go through here. There are different types of blood groups, but the most important one are ABO and RHD, because that's what is evoking stronger reaction than the other RH antigens. Therefore, we normally take RH. D. The others like Kel, Duffy, Yemen, they are all like minor ones, the less important ones, but you can go through them quickly. Okay, so RH mismatch in fetus is an important thing, or in newborn babies is a very important thing that you need to understand, because this used to happen very often in the past, but these days it's reduced because of the new technologies and new medical innovations that we developed. So what will happen here? If there is a mismatch of the blood, and if there's an antibody in the mother, we'll talk about it in the next slide in more detail. There will be a binding. So the antibodies will bind to the newly formed red cells of the fetus. Okay, so that will automatically lead to the lysis of red cells. So the most common antigen involved here is RHT because it's very antigenic and high frequency because of the positive blood group people. So the lysis, the increased amount of lysis of red blood cells will lead to enlarged liver and enlarged spleen because of the lysis. And it will cause anemic for the fetus or the newborn baby. And it can also cause jaundice due to increased amount of bilirubin. And we know that increased amount of bilirubin is toxic and it can cause even brain damage. So that's why RH mismatch in fetus has to be taken in seriously. So the same thing as I showed you before will happen when the antibody is produced against the new cells. They will bind and it will lead to lysis of the cells and it will cause the mismatch, cause the lysis. OK, so what's happening during RH mismatch, particularly for the fetus or newborn baby? OK, so here you got a negative mother. OK, RH negative mother. So we know that RH negative mother will carry RH negative red cells. OK, they are negative to them. So imagine if the fetus is developing here with RH positive blood. OK, for example, mother is A negative, but the fetus is A positive. OK, at childbirth or during any particular trauma, some of the blood cells can leak from the birth child into the mother's bloodstream. OK, so this is really important. At birth, there could be a chance that the blood get mixed from child to the mother, or if there is a trauma, then the RBC can cross the placenta and get into the child, get into the mother's bloodstream. So it's really important here. OK, so basically, the negative mother is getting exposed to positive blood during childbirth or other trauma. So what will happen after that? If we are not doing any action here, if we are not giving any specific treatment, the mother's immune system will raise antibodies against the RH antigen which came from the child. OK, so basically the IgG will be produced. So most importantly, as part of immune response, particularly from the IgG response, there will be some memory cells. These memory cells, memory B lymphocytes, will be circulating in the body throughout our life. OK, and upon the next exposure, these cells will kickstart immediately and produce the same antibodies again very quickly. OK, it's similar to vaccine response. When we give the vaccine, we are producing some antibodies and the antibodies will circulate only for a few days, but the memory cells will be circulating for a long period. So when you actually encounter the pathogen in your real life, then the antibodies will be produced from the memory cells very quickly. So the same thing happening here. So upon exposure to positive blood in negative mother, the immune system get kick-started, they will produce some antibodies, and most importantly, they will produce the memory cells. So now, during the subsequent pregnancy, so when the next pregnancy is happening, OK, and if next time, if the fetus is again positive to the blood, but the mother is negative, because we can't change that, now these antibodies will be produced again. OK, these antibodies can cross the placenta. OK, remember that only IgG molecules can cross the placenta, not IgM molecule. So when they cross the placenta, they will bind to the newly formed red cells and agglutinate and lead to lysis. And this lysis can destroy the growing fetus or cause lot of problems when the childbirth is happening. OK, so this is really important. You guys understand this RH mismatch, particularly during pregnancy Rh negative mother, if they carry Rh positive fetus during birth or during any trauma, the cells can get exposed to the mother's immune system. Therefore, the mother's immune system is producing antibody and memory cells. During next frequency, if the same mother is carrying positive blood baby or fetus, then the antibody can be produced and that antibody will cross the placenta and lyse the fetus. Okay, so this is inheritance of Rh. So mostly not the problem. Nearly 85% of people will carry positive. Okay, so when Rh negative is happening, so particularly or the mismatch is happening, particularly if a Rh mother is getting married with Rh father, then there is a chance that they will carry Rh positive fetus. Okay, but if the Rh negative mother is getting married with Rh negative father, there won't be any problem. Okay, so only during when positive or negative is getting mismatched, then there is a chance to produce this type of mismatch when the fetus is growing. Okay, so how can we avoid this condition, particularly by giving anti-D antibodies? Okay, if this is the case, if the mother is producing a baby with the Rh positive, but the mother is negative, then immediately after the first childbirth, you infuse anti-D antibodies. These antibodies produced against Rh antigen. So immediately within few hours, these antibodies will neutralize all the cells that came from the child, the positive cells came from the child, and then completely remove them before the immune system kickstart and produced memory cells and antibodies. Therefore, there won't be any memory cells. Therefore, there won't be any problem in the subsequent pregnancy. But again, in the subsequent pregnancy, if this is happening, that is basically the Rh mother, negative mother is carrying Rh positive child, then you need to give the antibody again in order to prevent any subsequent problems. So as I said before, in the past it used to be a huge problem, but these days it's not a big problem because of the availability of Rh D antibodies. Okay, so bone marrow transplant. So whenever we talk about blood donation and blood transfusion, we need to a little bit talk about that stem cell transplant or bone marrow transplantation, because it's really important. So mainly we are talking about hematopoietic stem cell transplant here, because there are several people don't have sufficient amount of their stem cells to produce the blood cells. Okay, again, refer to my first lecture on introduction to blood. So at any one time, around 120,000 people worldwide are waiting for bone marrow transplantation. It could be due to any health condition, for example, cancer and other problems. For example, cancer patients having chemotherapy or irradiation, all those things. Around 25 to 30% of patients find a match within their siblings. Okay, within their relatives, but nearly 70% people have to look for donors outside of their own family. So that's why it's really important to donate stem cells as well, particularly hematopoietic stem cells, or generally call it as a bone marrow transplantation. So there is a charity called Anthony Nolan Charity. They maintain a big register of donors who want to donate their bone marrows. So they in their register, over 800,000 people got registered at the moment. Okay, so when they find matches or when they find donors or recipients, immediately they will call their matched donors in order to get the bone marrow transplantation. It's really important. So when you're donating, again, similar to blood group, there will be a lot of tests that we need to do. Here, particularly, they need to do the tissue typing. Okay, so when you are doing the blood, there are only specific antigens that we are looking for. But when you are giving the whole tissue, there will be a lot of typing need to be done. Okay, usually they will take saliva samples from the donor and do the typings, and bone marrow will be harvested, or peripheral blood stem cells will be donated, and that will be infused into the recipients. For example, recipient who has chemotherapy or radiotherapy, because they will destroy their bone marrow and they need it. And donated stem cells can be injected by IV and migrate. They will get migrated into bone marrow to repopulate and produce the blood cells. And recipients should take immunosuppressant medication as well in order to avoid the rejection of these bone marrows. That's really important. At the same time, people who are taking already immunosuppressive drugs will also have reduced blood cells, blood stem cells. So they may need transplantation as well. So it's really important. Again, as sensible people, human beings, and as healthcare professionals, we need to consider donating blood and donating bone marrow. Okay, you can find lots of information in the blood.co.uk or NHS website, and about the bone marrow transplantation, you can find a lot of information in Anthony Nolan Trust website as well. Okay, generally, if you are a healthy person, you can give blood, okay, without any diseases. And for bone marrow, usually they look for people between the age of 16 to 30 years old, and generally you need to be healthy as well. So if you want to donate blood or bone marrow, you need to register yourself. You can go to blood.co.uk and register yourself to donate blood, and you can get more information about blood donation and transfusion as well. And for bone marrow, if you want to register, you can register on anthonynolan.org.uk website, and they will call you when they need bone marrow for matched recipients. So in summary, in this lecture, we talked about the ABO blood grouping system and the importance of this ABO blood grouping, and then RH blood grouping system, and why this is really important during newborn baby, for newborn baby and for fetus to avoid any mismatch. And we talked about the significance of incompatibility between the blood from donor and recipient, and what will happen if there is a mismatch and you transfuse to wrong blood. And we talked about the blood group determination, how to find out through agglutination test. And we also touched on the bone marrow transplantation and its necessity for our society. So thank you so much, and I hope you enjoyed this lecture. As I said right at the beginning, if there's any question, please email me or we can go through that in tutorial session. Thank you so much. Bye.